Today we read about dynamic equilibrium. As we have learned in our previous lectures that what is equilibrium? The state of system in which concentration of reactants becomes equal to the concentration of products, then this state is known as equilibrium, in which rate of forward reaction becomes equal to rate of reverse reaction and the equilibrium is achieved. So in order to study about dynamic equilibrium, we consider an example in which A react with B and form products C and D. Here A and B are reactants which are placed in closed container in gaseous state so that they react with each other and form products C and D. As they react with each other, they form products C and D in forward direction. So when C and D react with each other, they form reactant A and B in reverse reaction. It seems that when A reacts with B, it forms products C and D. It seems that reaction has stopped, but actually the reaction cannot stop. C and D again react with each other and form reactant A and B in reverse direction. Such type of reversible reaction in which equilibrium is achieved is known as dynamic equilibrium, in which two chemical reactions or two chemical processes continue in an equal rate in opposite direction. Here the product of concentration of product to the product of concentration of reactants must become constant, because the concentration of product and reactant becomes equal with each other at equilibrium. In order to study the graphical representation of dynamic equilibrium, we plot a graph between the rate of reaction on y-axis and time on x-axis. Here, as the concentration of reactants and products are directly proportional to the rate of reaction. So rate of reaction is directly proportional to the concentration of reactant and product. So here, if the at initial stage, when the concentration of reactants becomes very high, so after some time they react with each other and form products C and D. So forward reaction proceed here, in which A react with B and form products C and D. And when C and D products are formed, then they react again with each other and form product A plus B, which is reactant here in this case. So rate of reverse reaction will be start here. So rate of reverse reaction increases with the passage of time and rate of forward reaction decreases. A time reaches when rate of forward reaction becomes equal to rate of reverse reaction. Here rate of forward reaction becomes equal to rate of reverse reaction and the concentration of reactants and products becomes equal with each other. So here the concentration of reactant and product becomes constant. Rate of forward reaction becomes equal to rate of reverse reaction. Such type of equilibrium is known as dynamic equilibrium.